Hello friends. So in continuation with my previous video on sheet pile, in the last video you have seen how to draw the pressure distribution across the height of the pile, how to calculate the depth of embedment, all those things you have seen in a cantilever sheet pile. So today we would like to calculate the maximum moment, location of the maximum moment along the height of the pile. So in fact, if it is a sheet pile and this is the dredge line, you have seen in the previous video that the pressure distribution is going to be like this. This was P1 prime. Here the horizontal pressure was P2 prime, and then the pressure is further going like this. This was the pressure distribution diagram across the height of a sheet pile. This is the cantilever sheet pile. This is the sheet pile, right? And the top is A, bottom is B. You can call this point as D, this point as E, this point as F. So you can see that this distance was A, and P2 prime is given as Kp minus Ka into gamma prime, this is the water table, so multiplied by this distance A. So if A is 1, then the horizontal for one vertical, A vertical, this is the horizontal. So one vertical, you are going to have K prime, gamma prime, horizontal, where K prime equal to Kp minus Ka. Kp is coefficient of passive earth pressure. K is called coefficient of active earth pressure. Now, what is our objective? Our objective is to calculate the location of maximum bending moment and its magnitude. So let's say the maximum bending moment, the magnitude of maximum bending moment equal to M max. M max is the maximum bending moment. And if you see across the height of the sheet pile, the bending moment is going to change like this. So you need to calculate the magnitude of Mmax, maximum bending moment, its location. And once you know the magnitude of this maximum bending moment, this is the locus of bending moment, and this is the maximum. So if you can find out the maximum bending moment, then you can find out the section modulus of the sheet pi. So another objective is also to calculate the objective. This is the first objective, and the second objective is to calculate the section modulus of the sheet pi. Because you know the relationship, how will you find out the section modulus? We already know that m by I equal to sigma upon y. This is the famous relationship where m is the bending moment, I is the moment of inertia of the sheet pile, sigma is the allowable flexural stresses because it is going to bend. The sheet pile is going to be subjected to the horizontal pressure. So sigma is the allowable flexural stresses and y is the distance of the extreme fiber from the neutral axis. This is the famous relationship. Now, if you are able to calculate the maximum bending moment and say this becomes m equal to m max, which we have to calculate, and sigma equal to sigma allowable, which is equal to the allowable flexural stresses. Flexural stress of the sheet pi. Then this is known. If you are going to use the sheet pi of mild steel, what is the allowable flexural stresses? You know it, depending upon the type of the material you are going to use. This you are going to calculate maximum bending moment. And the moment of inertia, you can always find it out for any section. Therefore, you can say that the section modulus is I by y. So you can take I over here on the right hand side. So I by y equal to z. Z is called the section modulus equal to the maximum bending moment divided by allowable flexural stresses. This is called the section modulus. So you can calculate the section modulus because you have calculated the maximum bending moment, and the allowable flexural stresses is also known to you. Therefore, you can calculate the section modulus of the sheet pi. So now the question is, where is the maximum bending moment? You can calculate it very easily. Let us see how. So let the magnitude of the maximum bending moment equal to m max. Now, you know that the maximum bending moment will be where the shear force becomes 0. So this is the up from A DE, it is the active. So this gives you the area. If you calculate it, this gives you PA. PA is the total active thrust. In the last video also, we have been able to calculate this magnitude of PA. And if you remember, you can see the last video, it was 72.33 kilonewton per meter length of the sheet pile. So you know that what is the magnitude of this. Now here the sheet pile is going to bend it like this, and therefore there is going to be now mixed active and passive thrust. So what is going to happen here is, let's say at a particular depth from E, let's say at a depth Z bar, Z bar, the shear force becomes 0. So let us say that let us say the shear force is 0, where at Z prime, at distance Z prime from E, as shown in the diagram. So at Z prime, this will be equal to K prime gamma prime into Z prime. So this is the pressure distribution diagram in a cantilever sheet pile. So this becomes equal to K prime gamma prime into Z prime. Therefore, the force on this side, that is towards the right hand side, this is the force acting towards left hand side, and this is the force acting this. So calculate the force acting which is on this side. So at Z prime, the what is the force? The force is going to be equal to half into base, that is K prime gamma prime Z prime, multiplied by the height, that is Z prime. And now the left hand side, the force is active force. This is acting like this, and PA is acting this way. So if I take this force as positive, this becomes negative, must be equal to 0. So at Z prime, the force equal to 0. Therefore, the value of Z prime, where the shear force equal to 0, will be equal to 2 times PA. So it becomes 2 times PA divided by K prime gamma prime raised to power 0.5. So from this one, we are in a position to calculate the distance from E where the shear force is 0. So Z prime is given by 2 times PA divided by K prime gamma prime raised to power 0.1. Now PA is already known to us, 72.33 kilonewton per meter. K prime is 2.67 for phi prime equal to 30 degree. In the last video, I have shown you. Gamma prime is also known to you as 10.19. So we can calculate the Z prime. So let's calculate 2 into 72.33 divided by 2.67 into 10.19 raised to power 0.5 or under root this. So let's calculate this. So if I calculate 2.305 meter. So this becomes equal to 2.305 meter, or you can say 2.30 meter. So the distance where the shear force is going to be 0 has been found out as 2.30. Therefore, you can calculate the maximum bending moment. So now the force is PA up to A to E, it is going to be the active pressure, and from E there's the Y bar, that is the location of PA from E is Y bar, is known to you. And in the last video, we have been able to calculate the value of Y bar also. So you know this, that what is the value of Y bar. So having known the value of Y bar in the previous video, we have been in a position to calculate the maximum moment due to PA at Z prime will be how much? It will be Y bar plus Z prime. So PA into Y bar plus Z prime. This will constitute a anti-clockwise movement. Right? Now, what is the other force? This, if I say this point as F prime, so between E and F1 prime, this area, that you know it. So what will be the moment at Z prime? That you can easily calculate. So let us calculate that. So this will constitute the forces, you can find it out, which will be acting this way, and therefore it will constitute a clockwise moment, and it will be equal to half K prime gamma prime Z prime into Z prime, this distance. So base K prime gamma prime Z prime, half into base into this height Z prime, and into Z prime by 3. So the magnitude of the maximum moment, you can easily calculate it. So this is known to be from previous video. Y bar is already known. Z prime I have calculated. So if I calculate this, K prime is Kp minus K, gamma prime is 10.19, Z prime is 2.30 meter. So everything being known, Pa is 72.33 kilonewton. So everything is known to me. Therefore, I can calculate the maximum moment. So if I calculate, please refer the previous video also so that you can find it out. And if you calculate it, Pa 72.33 Y bar plus Z bar minus 0.5 into K prime into Z prime cube divided by 3. This comes out to be 280.99 or approximately you can say 281 kilonewton meter per meter length of the sheet pile wall. So friends, it is very simple to calculate the maximum bending moment along the height of the sheet pile, cantilever sheet pile. So now you know that M max is known to be. Having known this, the value of allowable flexural stress of the sheet pile is given to you as 172 megapascal. So this is given. You can always, depending upon the type of the material, you can always find out the allowable flexural stresses, which is called sigma allowable. So sigma allowable is 172. Now, how to calculate the section modulus? So to calculate the section modulus, it is very simple now. So I have now calculated the maximum bending moment and the section modulus of the sheet pile is called capital Z, is the section modulus, and that's you already know, that is, it is going to be the maximum bending moment divided by allowable flexural stresses. So therefore the section modulus equal to 280.99 or 281 divided by 172 megapascal. So in kilopascal, multiplied by this, so that you can calculate it. So let us calculate the section modulus. So the section modulus is going to be 281 divided by 172 10 raised to 3 gives me 1.633 into 10 raised to power minus 3. So this is 1.633 into 10 raised to minus 3 meter cube. So this is the value of section modulus in meter cube. And therefore, you know the dimension. For any cantilever sheet pile, what could be the dimension? Will depend upon the section modulus. So the section modulus you can calculate and you can provide the required dimension for the selected sheet pile. So what dimension has to be taken will depend upon the section modulus. Friends, I have explained it in very simple manner, and I hope all the points which I have described must be crystally clear in your mind. So this is quite important to calculate the section modulus, maximum bending moment, its location, everything I have explained you with the help of the figure. If you have any doubt on my Telegram channel, you can post it, and I will be going to the next video further explaining the pressure distribution diagram when the situation of the ground is going to change. So for today, thank you very much.